joining me. So, way back in 2013, Daniel Huffman shared that he used an open source 3D software package called Blender to do the hill shading for his maps and his cartography. He would layer that into his cartography with blend modes. Well, it's gorgeous work, and it like rolled over the map making world like something that rolls. And sometime later, Scott Reinhardt took that concept and he applied it to georeferenced vintage topo quads, so USGS topo quads or geology maps, so vintage papery beautiful maps, and he would overlay the hill shade from Blender on top of those maps and give them kind of new 3D modern digital life. And it was this beautiful old and new modeling that was happening, and it was beautiful. Now everybody's doing that, and they're selling posters of it and stuff. Sean Conway is just dug right in and makes a million of these things, and they're beautiful, and he tries different things. So it's a fun community that I'm not a part of. I'm not a part of this community. I've never made one of these maps before, but I've thought about it a little bit. I'm jealous, and I want to try it. And ArcGIS Pro has blend modes now, and so this I thought was like, okay, no more excuses. Let's try this. So I'm going to give it a shot. Well, first things first, I've Googled topo quad maps, and there's just loads of results. I like to go to the image tab, see what's going, and this one looks pretty good. Plus, it's in Wikipedia, so I'll visit this. Check it out. It's the upper eastern portion of New York, Adirondack Mountains. This might be a good candidate. Also, it's in the public domain, which of course is very helpful. Zoom in on this. There's a lot to like about this. It was printed in 1902, engraved in 1894, based on surveys done in 1891 and 2. That's so great. The datum is mean sea level, so we'll dig into that in a little bit. But check this out. Here's another thing that I love. The neat line is blown out, stepped on. Step on the neat line. Whoever was working on this, Henry Garnett, said, we've got this Adirondack Mountain Reserve here, and it's just going to get clipped. Let's just show the whole reserve here, because somebody's going to want to see that. Why make them grab another topo sheet? Isn't that cool? Thank you for doing that. I love it. Love that kind of charm and prowess in map making. I'm going to save this. I'll save this image as, and I'll put it into a data folder that I've got rolling for this. Topo quad. I'll save this. Now this is just a JPEG. What now? Well, here we are in ArcGIS Pro. It's time to georeference this vintage topo quad. Georeference? What the deuce is that? Georeferencing is magic. You breathe spatial life into an image. Push it and pull it, pin it, align it to where it belongs geographically, and an old map becomes plastered onto new geographic coordinates, and you can do cool stuff with it like you would with any other GIS layer. Okay, let's do this. So the first step that'll make our lives a lot easier is to pick a projected coordinate system that best matches the image that we're trying to georeference. So here's my image. Drop it right there. And Pro says, hey, heads up. By the way, this image that you just added has no spatial information associated with it, which is really cool of Pro to tell me that. Yes, I know. I'm going to turn this off for now. Let's define the projection of this map. So the coordinate systems tab, by default I've got this, but I was told by Dr. Boyan Shaurich and company, the geodesists at Esri, that it's likely that the 1902 printing of a USGS topo quad is using a local state plane projection. This happens to be northeast New York, and so I'll look for state plane, and there are loads of them. So I'll expand my window, and the oldest datum that I've got is North American datum 1927. It's not sea level, but that's okay. I'll use this one. So my map is going to be slightly off, but good enough for what it's for. Plenty of latitude for that sort of thing in the world. New York, so we've got central, east, the Long Island and west, and the best fit for me looks like New York East, 1927 state plane, New York East. Is it okay? Now our map is given that state plane projection. I'll zoom roughly to the area where our quad exists. It'll be over here in the Adirondacks. Okay, now I'll turn this on. This is just floating who knows where off in space. Now it's time to georeference. So there's this amazing feature in the imagery tab called georeference. Boom, georeference. Okay, when I do that, it adds a tab, and I can say I'm going to start adding control points. So I'll choose add control points. Now I'm going to zoom to the extent of this image. There it is. Here's something that's pretty cool. Very helpfully, this map has its corner coordinates labeled for me. So 45 degrees 15 minutes north, 74 degrees on the dot west. This is my origin point, and now I set the destination pin on my real life map. I can zoom out to see where in the world I am. Okay, and I want to be up here, likely. Now, right now, by default, my coordinates read out in decimal degrees. I'm going to use this as a reference for placing my pin. I'm going to change this to degrees, minutes, seconds, just like the topographic map has. Now I can see in degrees, minutes, and seconds. So the top left corner is 4415. So I'm going to look for 4415. Okay, so that's my first corner, and now hopefully all I need to do is pin my second corner to where it belongs. And because our underlying map is a near enough projected coordinate system to this map, everything within it should line up reasonably well. Here I go. I'm looking for an origin of 44 by 73, 45 minutes. Okay, whew! Let's see what we've got. It's like Christmas. By the way, you can fine-tune your zoom by right-clicking your mouse and just scrolling up and down. And you can pan by pressing down on your scroll wheel, and that'll let you pan around, FYI. Okay, let's see. Let's try swipe. Yes! Okay. We're good. Now we just save it, and it saves projected coordinate system information for this JPEG raster. Isn't that cool? Alright, now I've added it to the map. Now by default, ArcGIS Pro will take a look at an image and do its best to give you a good looking default view of this map. So let's take a look at what those defaults are. We've got a gamma value of 0.8. I want to keep it unchanged. So unchanged is just 1. The resampling type, right now it's the nearest neighbor. That can look a little jaggy. I'm going to go cubic, and it'll do some nice pixel dithering so that when I zoom in it doesn't look as jaggy. And then the stretch type, right now it's doing a percentage clip on the darkest and the lightest values, and they do that in order to boost contrast in the image, which is cool, but I want to keep it pristine, and so I'll just say none. Just show me the raw image as it is. Okay, there it is. A lot softer, but this is what the scan looks like, and so that's what I want to maintain. So I'll go to the georeference tab, close it, because we're done. Now we've got a georeferenced vintage topo quad sitting where it belongs. Isn't that cool? Now if I were to project this into any just bananas projection, this thing would warp and stretch and split and do whatever it needs to do to accommodate that projection. Spatial life. It's now become spatially sentient, and I love that. Check this out. Living Atlas of the World. The ArcGIS Living Atlas of the World has a glorious treat just waiting for you. Let me show you what I mean. I'll look for USGS. And there it is. Historical Topographic Map Explorer. Yes, please. I'll open this. This is an app that lets me search for any sweet, old or new USGS topographic map by place, and guess what? Also by time. Ready? Just click the area that I'm interested in, and a timeline pops up down here showing me the extent and a little preview of all sorts of USGS topo maps through the years, including what? Our 1902 Mount Marcy. Check this out. I'm going to zoom in. There it is. Look at this. And what? It must already be geo-referenced if it knows where to live in the real world. Download map. Here is a version of that map. This one's a little bit more tattered, which frankly is pretty cool. I like that even more, to tell you the truth. And even better, it's a GeoTIFF. GeoTIFF, watch this. Here is the map that we laboriously geo-referenced, but that was good to learn. And here's our GeoTIFF. Added right to the map, right where it needs to be. Isn't that amazing? And I'm going to do all this stuff. There we go. Already geo-referenced for us. Check out that resource. And frankly, all the other resources in Living Atlas. It's fantastic. And that does it for part 1, where we grab a beautiful vintage topo map and we geo-reference it and give it spatial life in a GIS. Part 2, we're going to grab a digital elevation model and we're going to clip it based on the extents of the map itself and also the whole paper. And in part 3 is going to be the fun one. Part 3 is where we dabble in hill shade and get crazy and have a lot of fun. So I'll see you there for part 2 and part 3.